In the previous class, we had stopped with seeing about the types of the classifications related to the fiber types of fibers that we can have, where it can be particulate uh, based on the fiber. That is, fibers can be in the form of small particles. Then it can also be in the form of strands, continuous or discontinuous. Okay, and then the other one is we can have it in the form of laminates also, right? Okay, right. So now let us see about these three things where the matrix, so based on the matrix, so the matrix can be made up of a metal, ceramic, or a polymer, right? So with that case, okay, so generally this classification based on the type of mattress is used. Metal matrix composites, where the mattress is made up of a metal. The metal can be of aluminum, okay, or iron, then copper, zinc, anything. So shortly they are also called as MMC, metal matrix composites. So if it is made up of ceramics, okay, then it's called as ceramic matrix composites, okay, so shortly called as CMC. And if the matrix is made up of polymers, okay, like epoxy and so on, they are called as polymer matrix composites, shortly called as PMC. Okay, right? So the what happens in metal matrix composites? So we can make use of aluminum, magnesium, titanium, iron, or tungsten. So anything that can be melted. So once it is being melted, these along with this metal, okay, the the fiber is going to be added up, stirred well, and it is going to be casted, right? So we can also have fibers in the form of carbon, silicon carbide, any type of those things. Okay, so the combination of these composites will have the mechanical properties combined by taking the properties of metal matrix. That will either we are going to make use of aluminium, then it will have some of the properties of aluminium, okay, and along with that they will also have what is the properties that for that the fiber is going to have in it, right? So both of them put together will have this will be the properties of this metal matrix composite. So here what will happen is, so if we generally if we should take up aluminum as the metal matrix, okay, and fly ash or any other is being used as a particles of fibers that is going to be add up into this. Okay, so these metals will be very much lower in density when compared to pure aluminium, because the fiber added up is also going to be a lower one. So say for example fly ash, okay, right? So if we mix up that, it is going to be a composite material, where aluminium is a metal matrix, fly ash is a fiber, particulate fibers, right? So fly ash is also light in weight, aluminium is also going to be light in weight. So the combination of this will have very low weight, but strength will be very high, because fly ash is has got little bit higher strength, and it has got very good wear resistance also. So these will be some of the properties. So this will have enhanced properties in strength, its elastic stiffness, okay, control in thermal conductivity, and so on, depending upon what is being added up. Okay, right? So that is the thing. So we will generally have to be, it will have low densities when we use oxides of alumina or titanium or dioxide and so on, right? So the next thing is about the ceramic matrix composites. So ceramic matrix composites. So here the matrix will be made up of a ceramic material which is very hard in its structure, okay, but very brittle in nature also. Like carbon and silicon carbide materials can be reinforced with it, okay. So which they are going to be very brittle, because ceramics have a very brittle nature, but high temperature, high melting point, high melting temperature they have. So this can be used in very high temperature applications, okay. So that is why the, say for example, if you look at the rockets, okay, the nose of the rocket, this particular region of the rocket is actually on the surface is made up of ceramic matrix composites. Okay, so because when it enters the earth, this rocket, there'll be so much of air coming at a very high velocity. The rocket is entering into the earth's atmosphere, so the temperature will be so much heated up, so the metals will generally get melted up. So this ceramic has got that property where it can bear that strength, but at the same time, since it is going to be made up of composite, it has got very lightweight also. So strength is also going to be retained at higher temperature. So in such applications, they will use ceramic matrix composites. Okay, right. So that is about the uh, ceramic matrix composites. So in such high temperature engine parts, the outer protective shields, okay, so they have to, wherever this is going to be exposed to higher temperature, but not more of mechanical load. So in that places, they will use ceramic matrix composites because of its brittle nature. Right. Polymer metal matrix composites, right? Polymer metal matrix composites, generally they are made use of polyester, epoxy, urethane, so many other polymers are present. So that will be usually in the form of a semi-liquid state. So that will be spread upon the in a box, okay, for the shape in which it has to be molded, right? So there will be this particular thing. So they will pour one layer of the epoxy resin or polymer, whichever polymer they are going to use. Then upon that, they will lay the fibers, okay, and then upon that they will pour one more layer of the polymer once again, and then again the fibers will be placed upon it, and a roller will be used so that the compaction takes place, so that the fiber is going to gel with the epoxy, sorry, with the polymer, so that there is a good bonding between the fiber and the matrix material over here. So these are going to be also going to have lightweight, higher strength also, right? So that is also another way of having this. So, but this cannot be used at very high temperature applications because the matrix is made up of a polymer material which has got usually a lower melting point. So there they can't be used, but it is very light in weight. Okay, so they are found in many industrial applications also, and aerospace structures and some of the automobile parts also. So as I told you, uh, the tanks of the KTM bike and FZ and all those things are actually made up of fiber reinforced composites. Okay, for this the matrix is going to be made use of a polymer only. But when you tap them, okay, it will have the sound similar to that of a metal itself. Okay, this is the same case when we have the mudguards for used for the two wheelers like Activa or Dio, Axis vehicle also, and not only restrict to that, some of the aircraft parts and bodies are also made up of this polymer matrix composites. Okay, right? So that for the aircraft we actually need higher strength with low weight, so that the the flying capacity is going to be increased. Okay, especially the efficiency is going to be increased. Okay, so some of the applications of composites, a polymer have about 5 to 10 times the specific strength than that of aluminium metal or aluminium alloy. So that means they have better strength when compared to even the aluminium alloys also. So thereby used in aircraft. Also, it is lighter in weight. Okay. The skeleton of aircraft is being built using aluminium based metal matrix composites nowadays. Okay. And some of the parts that we see like the radars, elevators, right? And one more special thing is that the blades of the windmill are also made up of composites only. The polymer metal matrix composites, sorry, polymer matrix composites only. They're also made by reinforcing fibers into it so that they are light in weight but has got high strength. So the main feature of all these composites will be usually high strength to low weight ratio, high strength to weight ratio. So they'll have a higher strength for 1 kg of this composite when compared to the same 1 kg of metal. Okay, right? So similarly, they'll have higher stiffness to its weight ratio. They will not be so much flexible. Okay, right? Corrosion resistance. Yes, flexibility in design. We can design complicated shapes easily, right? Okay. So yes, in automobiles, previously in the olden days and all, the piston and all those things were made up of cast iron. Okay, and that was nowadays replaced with then with later on with alloys. Okay, and nowadays they are coming up with some of the engine parts and other things and all automobile parts to be replaced with composites where they can reduce the weight, so it will increase the fuel efficiency and the speed also, right? So aluminum based metal matrix composites are used in engine blocks, piston, connecting rod and all those things. So that is why we see nowadays aluminum engines, right? Okay, so they are going to be light in weight. Okay, so and thereby the engine pulling capacity is more because the dead weight of the vehicle has been reduced by making use of this. Okay, right, yeah. And similarly, fiber reinforced polymers are used widely in the steering wheel, front and rear bumpers, the doors and interiors and all those things. So in spacecraft also they are going to make use of this for rotor casings, rotor blades, nozzles, panel doors, okay, and the structural members that is used to give the stiffness for the body, which we call it technically as structural trusses. Okay, fuel tanks are also made up of composites, as I mentioned earlier. Okay, yes, and in marine also they are being made, widely used for fans, blowers, and all. Right, condenser shells, yes, the stainers, gear cases, and so on. Yeah, we see some of the boats which will be usually in this dark sky blue color. Okay, they are actually made up of polymer matrix composites reinforced with glass fibers. Okay, so that is why that entire huge boats are molded as one single piece using this composite materials. Okay, right. So yes, of course, they are used in construction industries for doors, hinges, liquid tanks, that is to store the liquids. It can be anything, right? Okay, and many other applications. And even in electronics also, they find many applications where the frames made for the frames for switch boxes, frames for the solar panels, right? Parabolic antennas, road light canopies, etc. Right? So medical equipments, they find a lot more applications, okay, to replace the lost arms, legs, teeth, optical lenses, okay, and so many things. Yes, coming to the sports, the tennis rackets are all made up of actually, previously it was made up of metal, which used to be very heavy, but once the composites were invented, so they made replace the tennis rackets to be made up of composites, so they're light in weight as well as they've got very high stiffness also. Right, so similar they're used in golf rods. Okay, the archery equipment, bicycles, we see that we see bicycles which are to be lightweight, which we can lift it very easily. Right, all these are made up of composite materials. Right, so next, so this is all about the engineering that materials that we have. So next we shall go into the uh, the joining technique, okay, which is, okay, where predominantly we have three things. One is the soldering, brazing, and welding. Okay, so once these metals are being made up, okay, it is not always possible that we can have the metals or alloys or composite materials, everything to be to be formed to the required shape and size in one single piece, as a one single piece. It is not possible always. There is a need to join these metals especially, right? So there are complicated shape. Okay, if we take even the simple form of our desk, students desk that is present, okay, in our classrooms, right? So they are actually made up of the square rods, okay, made up of iron, and they are cut into the specific lengths and they are joined together. So how do we join this? One of the ways is to have by drilling a hole into the specified places and connecting the rods, the bars with a nut and bolt. The other thing is that we have to weld it. So welding, bracing, and all these are a kind of weldings are all uh, permanent joints. Okay, where the nut and bolts are all temporary joints. We can remove it when we don't need it. But welding joints are not like that. Once it has been welded, it cannot be separated. Okay, right. So let me start up first with welding, and then we shall see about soldering and brazing. Okay, so in welding, actually there are many different forms of welding, many different types of welding. There are more than 20 different types of welding processes that is present in this world. So some of them, say for example, it is what is TIG welding, tungsten inert gas welding, okay, MIG welding, metal inert gas welding, okay, electric arc welding is there, fusion welding is there, right, explosion welding is also there, right. So like this, many different welding processes are there. So what happens in this welding is that in welding, what do we have is that so metallurgical joining of two pieces by metals by the application of heat, okay, that is going to be there. And depending upon the type of welding process, without the application of pressure and addition of filler metal, may or may not be the application of pressure. It is not necessary, but it depends upon the type of welding process that we are going to choose. But as I mentioned, so it is going to be forming a permanent joint. So basically we can have these two things. One is the plastic welding process and the fusion welding process. So in plastic welding process, the pieces of metal to be joined are heated, okay, and to a plastic state, that is to a semi-solid state, and force them to get by external pressure. By applying external pressure, they bond to each other once they're in the semi-solid state, which they attain at very high temperatures. And they can be forged also. So some of the example are forged welding, where the force is being applied by hitting it with a hammer when they're in the semi-solid state. Resistance welding, spot welding, these are all the different welding processes that come under this plastic welding process. So fusion welding is about materials that are joined, okay, in the presence of heat, okay, to a molten state and allowed to solidify. There is no application of pressure in this case of welding at all. So some of them are electric arc welding, gas arc welding, thermal welding, and so on, right? Okay. So the next thing in this welding process, so before this welding is being actually carried out, what they have to do is they have to clean the surface of the metal where it is going to be welded. Say for example, if I take up two pieces of metal which is to be welded, and I'm going to weld in this particular region. I want these two edges of the metal 1 and metal 2, piece number 1 and piece number 2, to be joined over here. So this particular region has to be thoroughly cleaned first before the welding takes place, right? So there should not be any kind of impurities and other things, or oil contents, and all those things has to be removed, okay? Otherwise the welding will not be good enough and it will not have a good strength also. So it has to be cleaned first, right? And that is in the place where they come in, the surface, metallic surface that comes in contact, okay. And yes, so sometimes we'll have to use the flux, okay, that is to avoid the formation of oxides during the welding process, because if oxides are going to be present inside the weld region, okay, so when I weld metal 1 and metal 2, this is the welding portion. For example, here inside that there should not be any kind of oxides to be formed, otherwise it will start leading to corrosion. Okay, right. So that is why a flux has to be used to avoid these oxides to be present during the welding process. So yes, so types of joints we can have butt joint, where we are going to join these two metals one beside the other, and the other one is we are going to join the one metal over the other metal. So welding will be done over here, and here the welding will be done here in this gap, right? So this is called as a lap joint, placed on one above the other. Corner joint or L joints, so welding will take place in these corners. Okay, similarly T joint will happen to be at these particular places, okay, and edge joint also to be over here. So these are the different ways the joints can be done using welding process. Yeah, because we will be using some of the terms like butt joint, lap joint, right? So we need to know what is a butt joint initially. So I'll just explain this. The electric arc welding, the most commonly used welding that we even see in uh, the fabrication of metals, where they do these gates, shutters and all. So they will do this welding process where we can see a bright light that is going to be produced during this welding. So what happens over here, this is actually called as an arc welding or electric arc welding. So what happens in this arc welding is that this is an electrode inside which there is a metal rod. So this is the metal rod, okay, that is going to be there, made up of generally iron, okay, and this coating that is present surrounding this, okay, is nothing but the flux, okay, right, it is the flux, okay, and we have the base metal, nothing but the metal that has to be joined. So here we are going to take up a cut section to see how this welding is going to happen. So this electrode will be given a negative polarity generally, and the base metal will be given to the positive polarity, right? So when this electrode is being brought very close to this metal surface, okay, positive and negative polarity are very close together, so current starts to flow and an arc is being produced. So during this time, the temperature will be so high such that it will be about 4000 degrees centigrade. Okay. And since iron melting point is about 1248 degrees centigrade approximately. Okay. So, but 4000 degrees centigrade, this iron metal will melt. Okay. And it will form droplets and it is going to be deposited onto the base metal. That is the place where we want to join. And similarly, that is what is indicated over here as the molten metal pool, because at that high temperature, it is going to melt down as a liquid and it is going to adhere onto this base metal. And during this time, the flux will also get melted and produce a gas. Okay. And that will be forming a slag, a soft material called as slag. Once it has been solidified, that will be deposited onto the weld bead. Okay, so the weld bead is indicated over here as this hatch line, nothing but the welded material that is being deposited by molting, by melting condition in the liquid state. And once it has been solidified, we can clearly distinguish the base metal and the weld bead. The weld material also we can distinguish. So that is called as the weld bead. And similarly, between these two, the base metal that was previously present, because it was exposed to very high temperature, there will be a different color, okay, and its microstructure would have been changed, which we'll call it as the heat affected zone, right? Okay, as the heat affected zone. Okay, right. So we'll stop here for today and continue in the next class.